Good day, everyone. We are the BSS Math 3 students of Northwest Summer State University, and for this video, we're going to tackle the Tower of Hanoi. To begin with, we're going to provide some brief background information about this mathematical game. The Tower of Hanoi, also called the Tower of Brahma or the Lucas Tower, was invented by French mathematician Edward Lucas in the 19th century. The Tower of Hanoi is a mathematical game that consists of 3 rods and multiple discs. Initially, all the discs are placed on one rod, one over the other in ascending order of size similar to a cone-shaped tower. The objective of this problem is to move the stack of discs from the initial rod to another rod, following these rules. A disc cannot be placed on top of a smaller disc. No disc can be placed on top of the smaller disc. The goal is to move all the discs from the leftmost rod to the rightmost rod. Only one disc is moved at a time. When it is moved, it must be moved to another tower. Remember that a large disc could never be placed on top of a smaller one. Although it is not mentioned in the rules, the real problem is to use the least number of rules to move the disc so that all n discs end up on a specified different tower. Let's try to solve this using 3 discs. There are 3 discs placed on Tower A and 2 empty towers are to the right. The goal is to move all the discs on the last tower, considering all the rules of the Tower of Hanoi. So for 3 discs, we completed the puzzle in 7 moves. Now, let's try out using 4 discs. We completed the puzzle in just 15 moves. We observed that the Tower of Hanoi can be solved by a recursive algorithm. First, move the top N1 discs of the stack aside on Tower B. Second, move the N disc in position from Tower A to Tower C. Lastly, move a stack of N1 disc on the top of the N disc. Let us find the recursive formula. When n is 1, we have 3 towers. Only 1 disk in Tower A. Our goal is to move the disk on the last tower, which is Tower C. We just need to move the disk to Tower C. Then we're done. We completed the puzzle in 1 move. Let us do the same thing for n equals 2. We have 2 disks on the first tower and the goal is to move the 2 disks to the last tower. The first step is to move the uppermost disk and transfer it to Tower B. The next step is to move the bigger disk on Tower C. And the last step is to move the smaller disk on top of the bigger disk in the last tower. The total step is 3. T of 2 is equal to 3. Next, we have n equals 3. There is an easy way to solve this. We have 3 disks. Imagine we only named 2 disks. The goal is to move the 2 disks on Tower B. Remember that we already know how to do this because of n equals 2. We already moved 2 disks to the other tower. So, let's use the steps of n equals 2 to move those 2 disks to Tower B. We already know how many steps we need to take to do this. Now, we have those 2 disks on Tower B. So let us move the bigger disk to Tower C. Next, we have to move those 2 disks to the top of the bigger plate. We already know how to do this, so we just need to use the steps in T of 2. Then we are done on n equals 3. How many steps did we take on total? We used the steps of t of 2 two times. So t of 3 is equal to 2 times of t of 2. Don't forget that we have a single step in the middle, so we have to add 1 to the equation. 2 multiplied by 3 is 6, plus 1 is equal to 7. 7 moves. Let us do one more example to see the recursive pattern. We have n equals 4. We have 4 discs on tower A. Imagine that the bigger disk is not there, so we need to move 3 discs to tower B. We know how many steps it will take since we have already done this on n equals 3. So let us write t of 3. Now, we have to move the bigger disk to tower C, which only takes 1 move. We need to move the 3 discs on top of the bigger disk, which takes again t of 3 steps. So, the total moves are t of 4 is equal to 2 times t of 3 plus 1. We already know that t of 3 is equal to 7. We have 2 multiplied by 7 plus 1 is equal to 15 moves. We can recognize the recursive formula. We always multiply the previous steps by 3 and then add 1. Let t of n is equal to 2 times t of n minus 1 plus 1. Generally, we can say that t of n is equal to 2 times the previous step of t of n minus 1 and then add 1. Let's find the least move using 5, 6, 7, and 8 discs. Within 5 discs, we have t of 5 is equal to 2 multiplied by t of 4 plus 1. Then 2 multiplied by 15 plus 1 is equal to 31 moves. Within 6 discs, we have t of 6 is equal to 2 times t of 5 plus 1. Then 2 multiplied by 31 plus 1 is equal to 63 moves. Within 7 discs, we have t of 7 is equal to 2 multiplied by t of 6 plus 1. Then 2 multiplied by 63 plus 1 is equal to 127 moves. Then 8 discs, we have T of 8 is equal to 2 multiplied by T of 7 plus 1. Then 2 multiplied by 127 plus 1 is equal to 255 moves. Let us create a closed formula using the least movements of 1 to 8 discs. Write it on a table. The first row is n and the second row is t of n. We already found out that the t of 1 is 1, t of 2 is 3, t of 3 is 7, t of 4 is 15, t of 5 is 31, t of 6 is 63, T of 7 is 127, and T of 8 is 255. To find the closed formula, we have to look for a pattern. We always add powers of 2. So from T of 1 to T of 2, we are adding, and the next to 4, then 8, and so on. Our hypothesis is T of n is equal to 2 raised to n minus 1. Let us see the difference. 2 minus 1 is 1. 4 minus 3 is 1. 8 minus 7 is 1, and so on. As you can see, their difference is 1. That is why we have minus 1 here in our hypothesis. 2 raised to n minus 1. Let us try this formula. N is equal to 1. So, our hypothesis 2 raised to n minus 1 will become 2 raised to 1 minus 1 is equal to 1. Next, we have n is equal to 2. Our hypothesis 2 raised to n minus 1 will become 2 raised to 2 minus 1 is equal to 3. Then, we have n is equal to 3. Our hypothesis 2 raised to n minus 1 will become 2 raised to 3 minus 1. 8 minus 1 is equal to 7.
This is an example of a frequent mathematical strategy. If you have a series of connected problems, figure out how to incorporate the solution to each one into the solution to the next more difficult one. This is known as recursion. If you can find out how to solve the first problem, you can utilize that as part of the solution to the second. Then you may use what you learned to the third problem, and so on. Then, using this triply compounded solution, you could solve the fourth one and so forth. Because you will ultimately come to any of those difficulties if you work hard enough. You might declare that you can solve one of them.